Well, good morning and happy Sunday. Happy Easter Sunday for those who observe. This is PFG Live. Welcome. We got a bunch of people checking in. Let's see, on the Discord. First of all, checked in on Discord is DBX, Unix Carbide, Josh, Warren Jones, and Almost Machining. Light crowd, we expected that today. DBX is checking in with White Plains weather at 1556 Zulu. Winds are 290 at 13, gusting 19. 10-mile visibility clear. Temperature 12, dew point -01, and altimeter 2988. Warren Jones is checking in from somewhere in Sutton, New Hampshire, north of me. He says, I have no idea what the temperature is in Sutton. Hi, Spence, but it's sunny and nice. Nice. Unix Carbide is checking in from Williamsburg, Brooklyn, New York. 59 degrees, 42% relative humidity, 20.25% relative humidity in the micrometer drawer. Excellent. Josh is checking in. He says from Kilo 96 Delta, it is winds 360 at 8 knots, visibility 10 miles, broken at 2400, -7. I'm sorry. Dew point is -7, temperature -1, altimeter 3007. I don't know, cloudy, question mark? I should go outside. Yes, you should. Who else is checking in here? Josh says, audio check, thank you. Robert Simpson says 40 degrees Fahrenheit and cloudy near Detroit. And here in the Windham, New Hampshire, it is 52 degrees, 43% relative humidity, winds out of the northwest at 11 miles an hour. Not to be confused with Manchester Airport, reporting, 340 at 10, gusting 15. Visibility 10 miles. Scattered clouds at 6,000. Check. Broken at 25,000. I don't agree. I have clear above. And temperature 11. Dew point -03, altimeter 2980. Remarks are unimportant. So Robert Simpson says outside this time of year is overrated. Actually, it's getting pretty nice here, I have to say. In YouTube, we have Dan is in two places at once. Art that makes art. Wes says it has switched from rain to snow in south central Idaho. Wow. Jeff Loffert says gloomy and 31 degrees Fahrenheit with light overnight snow in Wasilla, Alaska. And we can see your house from here. CJ Stevens says hello, 72 and partly sunny in the only town named Strawberry Plains. Is it forever? I believe it is. So welcome aboard. So yeah, it is Easter Sunday. We're going to have a light crowd. I'm pretty sure of that. Lance K just checked in on the Discord. Welcome, Lance. I think I got everybody. So busy week, busy upstairs in the lab, busy downstairs in the shop. I know all you PFG Stones fans out there need to know the status of the pipeline. 4-inch regular stones are in the pipeline. Should be ready to ship on Monday. Tanda, it's funny. I was thinking I should tell Tanda to come on to the PFG Live. And here you are. It was telepathic. Tanda says sunny but windy here in ABQ, which is Albuquerque, New Mexico. Welcome. Nice to see you. Tanda is doing some flying and is posting some great little flying snippets, and it's firing all my neurons. It's like, I want to go flying. Anyway, so let's see. We're going to talk today about some things I learned. I have a card here, which I wrote down a few weeks ago, and this is a thought that I wanted to transmit. This will come as a surprise to no one, but here it is. It says, start before you know what you're doing. And I think that's a very healthy attitude for somebody who is finding their way through different technologies and areas of life. Is you just got to start. I heard it put another way once, which is you can't steer a parked car. And that's true also. So this not just heat treating process, but precision heat treating process has been pretty interesting. Josh says starting is the hardest part. It is. It is absolutely true. So here it is live, because we're doing it live. There is the ToolMakers flat TMF3. Woo! And it is fully thermally processed, as it was at the end of my last YouTube video, including grinding. So let me go over again what this process has been. For those of you who are just joining us and don't know what the ToolMakers flat is, which is acceptable, the ToolMakers flat is almost exactly a hockey puck. It's 3 inches in diameter. It's a little more than 1 1/8 inches, but less than 1 1/4 inches thick. It's 52-100 steel, which is the same steel that you will find in your gauge blocks. And we are making what effectively is a gauge block, not for its size, but for its surfaces. We want the surfaces to be very flat. We want the surface finish to be excellent, which is to say the roughness we want to be near 0, which is to say we want a mirror finish on both surfaces. So this project was instantiated as a result of a client coming to me with a requirement, which is almost exactly what we're making. And the client, and we'll talk about this more later about the specific work, but the client said something to me like, well, I'll send you the thing and you can do a best effort on it and then send it back. We'll be happy to pay you for your effort. And I said, you know what? Don't do that yet. Let me get my process together, prove to myself that I'm ready to accept your thing, and then you can send it along. So that's what we did. So that launched this thinking in my head. It's like, no, we should actually make this thing, and maybe turn it into a product. Tuck is here from Buffalo, New York. He says 47 Fahrenheit and sunny in Buffalo, New York. Wow. Thanks for being here, Tuck. We appreciate you. Thomas Hardy has checked in on the Discord. Welcome aboard. Everybody's getting back from Easter brunch. So I said to the client, I said, we're going to make a thing, and then I'll tell you to send me the first article. So that's where the idea came from. But then I put the word out on the Discord server. I said, hey, send me pictures of ToolMakers flats. So people did. And of course, Robin Renzetti had a spin on it. And he said, I put this deep groove on mine, and it's really nice for putting clamps on. And he sent me some pictures, and he sent me a reference to a video, I think, that had it in it. And I liked it. So I said, okay, we're going to take that idea. And, the groove became a thing. And you saw that on Instagram. So here we are. And we had to come up with a heat treating process. So I went back to 2 resources, one of them being Knife Steel Nerds, Dr. Laren Thomas. As you can see, this book has been well read. And the other one is the original, I shouldn't say the original, but the April 1960. So this is actually before I was, I had a complete bill of materials. Paper from the National Bureau of Standards entitled Gauge Blocks of Superior Stability, Initial Developments in Materials and Measurements. So this is part of an ongoing process improvement for gauge blocks. And boy, howdy, this paper goes seriously deep. Hey, Chop Smitty is here. Welcome aboard, sir. I think you're new to our group, and happy to have you. He says sunny and 82, as always, in, I don't want to get it wrong, Walcoloa, Hawaii. Welcome, sir. I don't get a chance to like actually practice how to pronounce this stuff. So this paper is ridiculous in its thoroughness about making gauge blocks and making very stable gauge blocks, in which there is a whole discussion of heat treating of gauge blocks. And I'm just going to put up on the screen. If you're on video, you can see that. The exciting conclusion, which I posted on Instagram, was a couple of key points. And it was not shown here is the temperature, is the austenitizing temperature, which is the hot one, which is 1050 Fahrenheit. And then they're quenching in a fast oil, not super specific, except if you read the paper, they talk about using a molten salt. So they use a molten salt for quenching, and then later they use a molten salt again, I think in the temper. We weren't going to use a molten salt, so we had to abbreviate the recipe. So the recipe that I am using is austenitizing at 1050 Fahrenheit for 15 minutes, and then it goes into the quench with a, quote, fast oil. In my case, it was 11-second oil from Quench Fast. And then after the quench, it goes directly into cryo to continue the quench down to cryogenic temperatures, and there it sits for a long time. Coming out of that, we do first temper. And if you look at step number 5 in the NBS recipe, they said a first temper of 1 hour at 250 F appears adequate. An extension of this temper beyond 2 hours or above 250 may induce some stabilization of austenite. They said austenite. That's it, austenite. So what they're saying is you do your first temper for a short period of time at 250. Now, what they don't say in that recipe that you're looking at, but it is in the paper, is that they say you do all subsequent machining operations at that point. Then you retemper. Then you cryo again. Okay, and then you retemper for the long temper. So the question came up as to why do you do that? And I believe it is in response to your subsequent machining operations, which in our case is surface grinding, actually introduces some stresses into the material, which is going to be relieved in the subsequent cryo and temper. So I had a question. I had a pair of comments on the YouTube video from somebody who, well, I will not identify because I think they were a little abrupt, which was basically, you should have ground it before the heat treating. I'm like, well, no, actually, I shouldn't have ground it before the heat treating, and there's a reason for it. The reason is we have to get it through first temper, then we get to grind, then we go back in because that's what the paper said. So after and then the second comment from this person, by the way, which was really funny. By the way, I completely recognize that I have entered the world of YouTube creators when I start getting these kind of comments. So I get it. And one day I won't be able to answer all the comments. But the second comment was, grind the damn thing already. Okay? Now, I will point out that his comment was on the video, 1/3 of which was me grinding. So I don't understand. Anyway, so we grind, we recryo, we retemper. Now the second temper is 250 degrees F for a long time. So this was 9 hours is specified. I did 10 hours. And then you let it cool off to room temperature, and you're done with your thermal heat treating. And that's where we arrived with this prototype of the TMF3. So when we came out of all thermal processing, Warren Jones, who is in the Discord, said to me, yeah, now you should go test your hardness, which is, by the way, completely correct. Because proper, I see Tanda's in Discord. Welcome aboard. And I will say, by the way, if anybody in Discord wants to do a video comment or question, you just say something in the doobly-doo there, and we will enable you to do that, and then I will pick you up and put you on the screen, whether you like it or not. So I went ahead, and if you remember the thumbnail for this video, let's see if I can bring it up. You'll see some black dots. Let's see. I have a better picture for you. There we go. You'll see some black dots, which was, I think you were smart enough to say that. These are Sharpie marks that are filling in the hardness tester points from the diamond. And those are the points that I measured in testing hardness after grinding. And this was a very smart thing to do. And what happened was I uncovered some interesting things. First of all, I uncovered that all of our measurements were above Rockwell C60. Okay. Target was 65. Initial measurements were showing some at 64, which was encouraging. But now I got, as an average, you see that group of dots that are in the center? There's 4 of them. That averaged out to Rockwell 60. And you see the dots that are outside that central group, and one of them has 2 dots. That I rejected one of those dots because I made a mistake. But those 4 locations, they came in at Rockwell 64. So what I observed was a lower hardness testing in the center of the ToolMakers flat and higher toward the edge. And this got me thinking. And in order to explain a little more of this, I just want to give you guys a mental model of what hardening is, okay? So when you look at annealed steel, I believe you're looking at what's called ferrite, okay? And to harden it, you heat it up and it becomes austenite, and the crystal structure changes. And I believe it becomes body-centered cubic. Somebody's going to yell at me. But it becomes a better crystal structure for what we want. And then you freeze it, and it becomes, let's see if I have a picture here. There it is. It becomes martensite. And martensite is exactly what you want. That's hard, okay? Martensite is a very strong structure, doesn't want to move, which translates to hard. The problem is that the act of going from the very hot temperatures, the austenitizing temperature, which we sometimes flippantly call red hot, okay, to quenching and making it, room temperature or so, that process doesn't happen instantaneously, and making it happen at the speed you want it to happen, which, by the way, isn't instantaneous and isn't a long time. It's somewhere in the middle. There's some magic rates that the folks that figured out all this heat treating want to make it. So in order to do that, you have a process which includes a mechanical, how you handle the material, but also what your quenchant is. So, typical quenchants are water, oil, and air. We love A2 tool steel because we heat it up in a little envelope, we pull it out, we put a fan on it, and it quenches in air. And that's really cool, and nothing's splashing around, and it's pretty neat. Yes, I did say really cool. But this stuff, 52100 steel, wants to be oil quenched. And if you read the paper, they say, we have a better way than oil quenching. I'll get to that in a second. But typically, we would oil quench it, and the quenchant oil of choice is a religious argument. So I go to McMaster Car, and I buy a jug of, actually I bought 5 jugs of 11-second oil from a company. Well, the product name is Quench Fast. That's a great name. And 11-second oil denotes its speed. They also have a slower one, which I think is 30-second oil. And so anyway, it was the right stuff for this process. Now, the NBS, if you read their paper, they did samples in that process, but they also did samples that were using, I have to get the term of art. I think Robin, using a salt bath. I can't find it right now, but they quenched in a molten salt bath, which brought it down very quickly to about 300 or 400 degrees and held it there for a period of time. And then they took it down the rest of the way. And there's reasons. And if you want to read the paper and become an amateur or professional metallurgist, have at it. But that was something we weren't going to do. Let's see. Unix Carbide asks, is fast quench allowed to produce a slow quench oil? I will get back to you on that, sir. I have to check with the lawyers. Anyway, it works. You heat your stuff up, you do it for the right amount of time, and you go. So we had these. So now you know kind of what's going on, and the way to think about this is you're turning. You're freezing. He's effectively freezing the crystal structure, and you want everything to turn into this new stuff called martensite, but it doesn't. So you have, then the evil words are retained austenite. So you have some of the material, some of the crystals are still in the austenite phase or configuration, and you don't want that. So it turns out that quenching to room temperature is insufficient to convert all of the martensite to, all of the austenite to martensite. And there's a great graph in Laren Thomas's book, which shows that, okay? And it basically shows, well, if you just quench to room temperature, you're leaving money on the table. Okay. You have to, the colder you get it, the more you get a conversion from the martensite, from the austenite to the martensite. Just remember AM radio, it goes from A to M. Okay. So we want martensite. So that's the reason for cryo. Let me say it differently. That's the reason for refrigeration in the quench. And if you do more research, you find out that colder is better. So they used minus 140 degrees Fahrenheit for their temperatures. It turns out that that's the limits of mechanical refrigeration. That's where that comes from. You could make a minus 140 degree Fahrenheit freezer. You can go buy one today, and that'll do that. But liquid nitrogen is a whole other class, and that goes down to minus 300 something degrees Fahrenheit. And it turns out that that's good. We like that. So I use liquid nitrogen. I've said this before, that other books warn you that the world will come to an abrupt end if you do not temper your steel once it hits room temperature. And that, of course, was the Bryson book. And because the Bryson book has chapters on every steel, and if you go through the book, every chapter will start with that. It will say, temper immediately. It comes from some other things, and it gets amplified incorrectly. But it turns out that the going into the cryo is part of the quench. So we get it cold, we get to room temperature-ish, and then we quickly get into the refrigeration. Another fact you get from the research is the time between getting to handleable, room temperature, and getting it into your refrigeration is inversely proportional to how cold you're going to get it. So if you're going into liquid nitrogen, you could take an hour to get it into liquid nitrogen and get 99% of the effect. Whereas if you're only going into dry ice, which is about minus 150, I think, you have to do that within less than 10 minutes. Not too bad. But again, more evidence that the liquid nitrogen is the way to go. So you get it down to quench. So we did that, and it worked out. It worked out great. In fact, if you watch the video, so we did 2 videos, minor branch here to talk about videos. 2 videos have been released on the ToolMakers flat, and they blew up, and relatively blew up, but they have probably 5 to 10 times more views than other of the videos that I recently published. And there's a few reasons for that, but people are very interested in this particular topic. And one of the things I did was come up with a way to use the liquid nitrogen using Amazon stuff. So we got my doer that I store liquid nitrogen is off of Amazon, and then the container that I'm actually doing the liquid nitrogen soak in is a big, rather nice actually beverage container, 1 gallon beverage container, and I put that into a styrofoam cooler that I have laying around and stuffed foam around it, and it worked awesomely well and did not cost $1 million. Jeff says, were they quenching in a salt brine rather than a salt bath? Molten salt baths are 1474, which is a bit warm for quenching. I am going to have to get back to you on that. All I know is that their most optimal process, and they tested at least a dozen different processes, but their most optimal process involved molten salts, and I was not going there. But they did also test in oils. And what they were looking for, so what the NBS was looking for was not only to achieve the hardness, but to have the minimum retained austenite, retained austenite. Because what happens is over time, let's say you do your quench, right? So you go bloosh into your quenchant, and there's going to be a percentage of retained austenite. That austenite will convert to martensite over time. So if you have a high percentage, then a lot of material over time, slowly, is going to convert to martensite. You ever hear like Bridgeport, when they made their castings for the Bridgeports, for the milling machines, they would throw the castings out back and let them sit in the weather for 3 years before they started building a mill with it. Part of that is that the material is settling, and that's the technology they had available to them. The same thing happens with the retained austenite. It is converting over time. So if you make a gauge block, okay, this is what the NBS cared about, and it had retained austenite, then over time its length is going to change. And that's what this whole paper was about. They were measuring gauge blocks processed under all of these different recipes, and then they were measuring them at least a year down the road, and they were looking at size changes. Then they did crystallographic analysis to further quantify the retained austenite. So it was pretty neat. Robert Simpson says the same with BMW racing engine blocks. Yeah. And now I'll tell you what it says in the good book, which of course is the Moore book, the title of which escapes me at the moment. But in the Moore book, they said, yeah, the Moore machines are also made out of cast iron, but we know how to do it so that it's stable and we don't have to wait around for 3 years. That was a real dig. I wish I had that ready for you, but I don't have the quote. We'll see if we could dig it up. But it was Fundamentals of Accuracy is the name of the book. Great. Okay, my brain just came up with it. So foundations of mechanical accuracy. And they basically said, yeah, they do that. And by the way, we don't have to do it because we know how to process the cast iron. True story. Look it up. Anyway, so for the Toolmakers flat, let's get real again. For the Toolmakers flat, we're definitely not looking at a dimension over time, but we are interested in it staying flat over time. So we're trying to get as close to perfect as we can because that's what we do. Hey, AB Shop is here. He says, rainy here near Venice. That's the real Venice. But perfect for getting together to eat for Easter. Excellent. A big ciao from AB Shop in Italy. Welcome and nice to hear from you, sir. Awesome. So we're trying to get the bubbles out of the resin. We're trying to get all that stuff processed out so we are left with a uniform, magnificent martensite, which, by the way, if left to its own devices, is going to be in the high 60s of hardness. The fact that, well, we'll get to that. So that's the quenching. Now, when we temper, we are we're actually doing a partial conversion to get back some toughness in the material. Some of you who have done heat treating before heard the temperature 250 degrees F, and you're like, that's like nothing. Correct. That's like nothing. Because if you read the paper, they specifically say they were interested in getting enough tempering to stabilize the material, but not to start converting some back to get some toughness, which is, again, literally a conversion. So 250F was intentional. The target there is Rockwell 65. The best we saw was Rockwell 64, well within our tolerances. But the center only got to 60, and we measured it, and it's real, okay? And this caused me some consternation. So I was wondering why we only got to 60. So I came up with a couple of theories. The first theory is that the length of time I spent at the austenitizing temperature of 1550 Fahrenheit wasn't enough. So the 15 minutes came from Laren Thomas recipes and also from the NBS. Actually, I'm not sure if it was from the NBS paper. I had two sources. And now I realize that those samples that they were dealing with may have had sufficiently lower mass than this bad boy, okay, that maybe I need a little more. So I decided to increase to 30 minutes from 15 minutes my austenitizing time. Now, the question is, how much is too much? So I did some reading on that. Well, it turns out that really when you get up to an hour or so is when it's too much, or 2 hours is too much. But going from 15 minutes to 30 minutes doesn't seem to be harmful, and I think it will result in more complete soaking of the material and getting it up to temperature and getting it converted. So that's one thing I'm going to try. And the other thing came from a drive-by comment by Mr. Tom Lipton, who commented on the video. He says, did you warm up your quenching oil to 140 degrees when you quenched? And I said, no, I didn't. It was room temperature. And then I said to myself, Tom, come on. If the oil is cold, it's going to quench faster. That's logical. It's completely logical. It's also completely wrong. So I dug up a paper on quenching oils and how they're used. And by the way, the knife guys know this already, right? If there's several knife guys listening to this laughing. And in fact, I found a knife maker who was using an ammo can with oil in it as his quench tank. And you're watching his process, and he puts like this heating element from a roaster into the oil before quenching to bring it up to, I think they were using 125 degrees F. So there was clearly some validity to this. And when I did the research, it turns out, yeah, there's like 4 stages of what goes on when your super red hot thing drops into the oil. And you actually get better quenching performance by having it start at 140 degrees or 120 or 150, depending on, who your grandmother is. You get better quenching performance than if you do it cold. And oh, by the way, my room temperature, it's sitting on a concrete floor, so it's really 55 degrees. So the other theory was, or hypothesis is, well, the center chewy part of my toolmaker's flat might not have quenched properly because my quenching oil was the wrong temperature and it wasn't as effective. So that's the second change we're going to make. We're going to heat up the quenching oil to a magic temperature, which could be 125 or 140. We'll figure it out for our second test. So I ordered from Amazon. Oh, so the first thought was I have these magnetic engine block heaters already in stock, which I tried and rejected for the coolant tank heating. See previous videos. And upon using those, so I couldn't use those. They were underpowered. I ultimately went with an immersion 800 watt heater. But I said, oh, I could attach these to the side of the bucket, which is steel, and heat up the bucket. Well, I tried it. I don't like it because the thermal contact was poor. So I said, let me look to see if the same company that made those things makes some pads that go on there. My friend Adam Brunette, MHM Machining, he's building this huge, he has built this 4x8 feet or 4x6 feet 3D printer. And his bed has these silicone heating pads under strategic parts to do the bed heating. Sure enough, I found a 115 volt AC heating pad that's designed to be adhered to an oil pan. It was 250 watts. Perfect. So what I'm going to do is I'm going to take that and I'm going to adhere that to the side of my steel bucket. And I got a controller. Oh, Jeff says, depends on the oil. Parks 50, which is a fast oil per the manufacturer, should be used between 70 and 120 F. They recommend room temperature oil, and then don't let your items heat it up any more than 120. Excellent. I will be doing more research with the manufacturer of our oil and see if they have any specific recommendations. But I also got another controller, which is the same one I use on the coolant tank. So we're going to have a temperature controlled quenching tank. So whatever number we come up with, Jeff, be it 120, even 70 or 140, right? These are all numbers I've heard. We're going to be able to dial it in and bingo, let the robot make the temperature right. So I'm pretty excited about number 2 coming up. Does this Does this inhomogeneity of hardness like kill this thing? No, I think it's fine, and we will be lapping it. Evils is here. Welcome aboard, sir, from Ghent, Belgium. He says, reporting a very late 19 degrees science and 63% relative humidity, only hundreds of millimeters away from my blasphemous carrot chili. Dude, I would eat your carrot chili. Let me just say that out loud, okay? I respect your carrots. Welcome aboard, Evils. So yeah, we're going to continue to finish the first prototype. I think it's going to lap beautifully, okay? And, everything is north of Rockwell 60. I'm unconcerned. But the second one is going to be very interesting. There it is. DBX put it into the chat. I'm not even going to explain this. I'm just going to let that hang. It's a new sticker that says you can't just carrot things willy-nilly. That's chaos, from Bakafish, who's not here to defend himself. Yeah, Tanda says, good point, Jeff. You need to start on the low end because the part is going to impart heat to your quench as well. Yes. And again, we're not commercially heat treating here, which, by the way, that was Robin's recommendation. He said, yeah, send it to Solar Atmospheres and write the check. So if we do get into production on these ToolMakers flats, okay, I will probably have them do the majority of the heat treating because that is their business and they are good at it. And at scale, it'll be more cost effective for them to do it than for me to do it. And we did it in no controlled atmosphere. So we got oxidation that we knew we were going to get. If you look at the edges, you'll see it's discolored. That's been wire wheeled, right? And just watch the videos. You'll see what it looked like. Whereas if we get it vacuum heat treated, it's going to come out pretty clean. So that's pretty nice. So again, this is in the prototyping stage. If we do go to production, we'll have them do it. Now, I may still have to do a cryo and a temper. No problem. I've got a perfect low temperature oven for that. We've got the cryo capability for that. We could take care of it there. So next step for this guy is lapping and done. So we're going to lap this to ridiculous and we'll see what happens. So, yes, we're going to heat the oil and it's going to quicken the quench, which is amazing. It's still, still amazing. We got another comment on the YouTubes that says, does the temper negate the cryo? And the answer is no. So the temper is at a very well-controlled, accurate temperature to get exactly a well-controlled thing. What's my analogy for this? So how many of you, raise your hand if you like steak? You like steak? I like steak. Okay. And there's a lot of ways to cook steak. You could fire up the grill outside and you walk over and you take your steak and goes onto the grill, and a good grill meister will know when to flip it. Okay. I like to poke at it and I actually measure the rebound and the consistency. And when I think it's time, gets flipped over. And then again, same thing, watching the juices and pulling it off. So that's one way to cook steak. Chop Smitty says, I use Hansen/Bulk in Grand Rapids, Michigan for heat treat. It's witchcraft to me. So thank you for that pointer. We'll keep those guys in mind also. Now, another way to cook steak, some of you know where I'm going with this, is a technique called, anybody want to guess? I know somebody's going to get it. I'll give you a minute. The bag thing. Robert Simpson is correct. It's the bag thing. Can't spell it. Yeah, okay. It's sous-vide. Okay. Sous. The word of the day is sous-vide. Sous S-O-U-S, vide, sous vide, French. So in sous vide, you take your beautiful cut of meat, you put it in a bag, having already seasoned it. By the way, I did a controlled experiment with a matrix of 4 different seasonings. Believe it or not, the best we found was salt and pepper. A good, freshly ground black pepper and salt. So you do your seasoning, you put the steak in a bag. I bet you didn't think we're going here today. You seal the bag, you put it in a water bath with a very good temperature control. And I like to use 129 degrees Fahrenheit. And you bring the temperature of the bath plus your steaks up to that temperature for hours, okay? Not less than 2 hours and not more than 2 years. No carrots yet. No, actually, take it back. There's a good picture. DBX put a picture up of a temperature controller and a water bath. There it is. Thank you, DBX. So you could people do put carrots. Actually, people sous vide vegetables. That's not what we're here to talk about, please. Okay? Leave your vegetables for another day. But yes, you could put vegetables in it. You could do vegetables only. You could do all sorts of stuff. It's great. But let's get back to the steak. You bring it up to 129 degrees for hours, okay? When you are done, it turns gray. It turns this interesting shade of gray. You can eat it at that point, but you're really not done. So you now take the sous vide steak out of the bath and you finish it. You can finish it on the grill. You could finish it on a griddle. I use a cast iron pan that has the griddle fins in it. Where's A-Bomb? Where's A-Bomb? He's on the road. Sorry, we can't bring A-Bomb in. And high heat, hit it, right? Put butter on it. Okay, so now you got butter on the steak in the hot pan. Flip it. Okay, I think I do 45 seconds per side, and I do it twice to get the grill lines 90 degrees on each side. Woo-hoo, okay, I'm starting to drool here just thinking about this. And then, boom, you're off. And what do you have? You have the magnificent Maillard reaction, causing that nice, crispy, yummy crust. And then you have, if you look inside, your steak is perfectly done uniformly throughout the steak. Now, your buddy who just finished cooking the steak on the grill, you cut his steak open, and what do you see? You see a gradient from the top surface of the steak to the center of the steak, where it goes from very, cooked, but then it transitions down to whatever you wanted to hit, medium rare, whatever. So the sous vide is very uniform because it's done at a specific temperature for a long time. Okay, what does all that mean? It means that tempering is like sous vide. Okay, it causes some conversion back from martensite, and it does some stress relief, but it hits you do it for a long time. You can temper for an hour or 10 hours in your final temper, okay? And that's exactly like sous vide. Okay, that's my mental model for this process. Jeff says, now I want to go grill our rack of lamb. And it's not even close to dinner time. I know. I'll be there. Just send me an address, DM me the address. Rack of lamb, I'll be there. Yeah. Why did the combatants not knock down the big wooden door to the castle? Because they had a lack of ram. I'm not sorry. So that's the story. Much was learned. The liquid nitrogen consumption in the cryo was much less than I feared. At $75-85 for 10 liters, that's good. Yeah. Oh, thank you. So DBX gave a photo credit. I appreciate that. Catherine Frey, The Washington Post, via Getty Images. Thank you. Okay, so does the Temper negate the cryo? It does not. The cryo is your friend when it comes to eliminating retained austenite, also known as RA. So that's where we are. I think you're all up to date now on the Toolmakers flat. Those are all the nitty-gritty details. This 3D printed ring is designed to keep your hands off it, and it uses our deep groove that was designed by Mr. Robin Renzetti. And if you want to use your deep groove, you just take the screws out of the ring and you set it aside. Now you'll be amused to know that this ring is at P3, which around here, stands for prototype 3. Stand by on the sticker there, DBX. And here's P1. Okay, so P1 just had a couple of holes, and I put a screw and a nut through it. And that was nice, except the screw and the nut were just in the way and ugly and sharp and terrible. So this was P1. And how long do you think P1 lasted? Anybody want to guess? The standard rule is that P1 lasts 15 minutes. And that's okay, as long as you accept the fact that on any project, P1 lasts 15 minutes. There it is. There's a new sticker. P1 plus 14 minutes. You've got 60 seconds left. So P2 was a disaster, and P3 is what we're using. Tuck asks a good question. He says, what does one use a Toolmakers flat for, or was that answered already? A Toolmakers flat can be used for a lot of things. For example, you could ring a gauge block to a Toolmakers flat and then put your part on it and then use an indicator to compare the gauge block to your part, or your gauge block stack to your part. That's a very classy way to make that measurement. That's a comparative measurement. Another way is that you're just measuring the height of something very precisely. So you put it on or ring it to the Toolmakers flat, measure to the top of the Toolmakers flat, measure to the top of your part, and you've made a precision measurement. Those are examples of how you would use a Toolmakers flat. But it is ringable, so you could ring a gauge block stack to it, and that's a very nice way to do it. Unix Carbide shows us one of his P1s. Very nice, excellent, written in purple Sharpie. Extra points for using purple Sharpie. Good question. Chopsmitty says, hours on the Traeger smoker with meter temp probe, then straight to cast iron for reverse sear. Coffee and macadamia nut rub. Free tip. Dude, I don't know what we're having for dinner tonight, but it better be proteinous. We'll see. All right. I'm going to turn off that picture. Robert Simpson says, be sure to get purple and not lavender Sharpies. There is a difference. Thank you, sir. Let's see. Also, Mr. Tim Zawada, who is a regular here, who apologized. He says he wouldn't be able to attend because of Easter festivities. He says, regarding your teaser, which I posted on Instagram, tempering does not negate the cryo. The cryo transforms retained austenite into martensite. That will increase the hardness of your steel. The newly transformed martensite should be tempered to avoid stress problems. If you keep your tempering temperature below 300 F, you will not soften the steel from its as-quenched hardness. Excellent. Thank you, sir. We communicated during lunch this morning, and that was really nice that he was able to give me a little bit of wisdom He says also, Tim says, an alternative to heating the room temperature oil to increase the quench speed would be to go to a faster oil. Park/heat bath/Dubois number 50 is much faster than 11 seconds. I hope all this helps. So I don't know what the 11 seconds means, like literally means. I wouldn't take it too literally, but it is just the name of that particular oil. But I'll look into it. And I know that the knife guys were talking about parks all over the place. But for the moment, I want to keep that variable constant and just change the other variables. So that's what we're going to do. Let's see. Almost says, your quenching is a very interesting partial differential equation of heat diffusion on a disk. Since your disk is of different thickness in the boundary conditions change. Yeah, my head hurt thinking about like what's going on when you do that quench from a thermal point of view. So, we're not taking a scientific approach. We're taking an engineering approach. So if we turn a couple of knobs and everything gets fantastic and it stays fantastic, we're just going to go with the settings on those knobs. I am not going to instantiate a research project onto why that happened. For example, I've just said to you that I'm going to heat my oil. That's one change. And I'm going to increase my austenitizing temperature soak time. And that's the second change. If everything suddenly gets magnificent, my recipe is my recipe. It's like grandmother's roast, right? It's flat on both sides, and everybody wondered why her roast is so good, and they figured they have to keep cutting the flats on the sides, but it was because her pan was too small. All right, so that's the story. That's ToolMakers Flat 3, and we will continue to lapping. The next video will probably be about lapping, if not the only video about lapping. If we're lucky, but probably we won't be lucky, and we'll have to do some things there too. Finally, I did a project for DBX in. Thank you, Tanda. Thanks for checking in. I did a project for DBX in 4142 pre-hard steel, in which we had to drill and tap 1.6 inches deep through 5/8 11 thread, and the material is 4142 pre-hard. This ate my lunch. I love 4142. I love machining 4142, but internal long tapped threads I had not done before in 4142. I ended up buying a tool, thank you very much. A DBX put up a drawing of the part, simple part. So I bought this tool from Redline Tools, which was a tapping tool, or a threading tool for the lathe that was able to accommodate that depth. And it required a 1/2-inch hole, which we happily were able to give it. But boy, I had no end of grief making that happen. And there's a couple of things that went on. Number one, they only gave me this tiny, it was a 1/2-inch long shank for a tool that was 2 inches long. I didn't understand that, and I didn't like it. And is that to blame? Not sure. I held it as best I can. Long story short, I chipped the tool on the second one, and even the first one didn't come out too good. Tapping it was a bear with a full-size tap, but the taps I had were junk. So basically, I'm frustrated. So any advice and counsel you can give me, I would be very open to. I've got 2 brand new taps coming from McMaster-Carr. One of them is a taper tap, so it has a long nose to reduce stresses. That's on the way. And then I have a regular, kind of what we call a normal tap. I forget the name of it. I did not order a gun tap because they didn't have one in that size. Yeah, I think it's called a plug tap. Thank you, Robert. It's not a bottoming tap. I think it goes bottoming, plug, taper. So I have a taper and a plug coming for 5/8 11. I did not see the coffee is flat lapper. The coffee is still on, man. Welcome aboard. I didn't see a gun tap. Usually I like gun taps for this. So a nut tap, Robert Simpson teaches us, is an extra long taper. Thank you. I didn't know that. No, I didn't see those either. So we'll see what happens. Or this is exactly where I was going, Chop Smitty. Helical interpolation, single point carbide on a VMC. So I have a thread mill. I could have done that. But that's on the list. I just want a roll tap. Really, almost. Can I come watch you roll tap 4142 pre-hard? Because I want to see this. Honestly, boy howdy, I would be super impressed. Yeah, I know. It is driving me nuts. Used to do it in 4340. 43. Okay, so I need to learn. Please teach me. If you could roll tap this stuff. It also needs a little bit of poop, doesn't it? I don't think I can do that, frankly, on the lathe. Anyway, we'll get there. I think the new taps, Molly D, absolutely yes. If any of you are on Practical Machinist, the forum, and have been for decades, like I was, that was a running joke that Molly D will actually drill and tap the hole for you. You just put a drop on the work and you're done. Yeah, Molly D. I do have some. So between the new taps and Molly D and coming to my senses, I think it's going to be fine. The other approach is to take 4340 and it's annealed condition and then heat treat it after machining, right? Almost thinks that my new taps plus Molly D is going to do it. So let's see if he's right. Yeah, and DBX was feeling bad because this was a project for him. And I'm like, dude, if I wasn't faced with this, I wouldn't learn all these things. And at this point, throwing a piece of stock in the lathe and hitting the button, I've got the outside dimensions are like, I could do those in my sleep. Anyway, a lot of fun, learning stuff, having a great time doing it, and we will get that part done. Do I have a floating tab holder? No, they all sync. Actually, I do. I do have a floating tab holder. Yeah, Evils correctly says, I guess the important part is that you change something and know what that was. That's why we call it science. Or engineering. Engineering just stops when everything works. All right, well, with that, if you guys have any questions, put them up now. It's question time. And if nobody has any questions, we'll wrap this sucker up and let you get back to your leg of lamb or your rack of lamb ribs or your porterhouse steak. Anybody? Any questions? Okay. Are PFG stones okay for reconditioning caliper jaws? Hey, take care, Jeff. Thanks for being here, man. The answer is yes. I use them for caliper jaws, absolutely. I will say this. Thanks, Almost. Almost says, good stuff on process control. Amen. The way I make PFG stones, the opposite sides should be parallel. But it is not a focus of the process. So I don't guarantee them to be parallel. So the answer is yes, and they should work. And let's see, Unix, where are you? Hang on. I'm bringing you in. Stand by. Unix Carbide, hello.
Hi. Excuse me. When are we going to get PFG gauge blocks?
I will
Sorry
not
to put
be
you on the spot.
You did put me on the spot. No, we will not be making PFG gauge blocks. There are plenty of outstanding gauge blocks out there for about 37 cents. And I will not be making gauge blocks.
All right, so maybe a topic for a future show would be actually all about gauge blocks.
All about, you want to do an all about gauge block show? Because let me tell you.
Why every home hobbyist needs a Mitutoyo ceramic set.
No. You can't do that. No. That doesn't work. You can't. No. He left. He just walked out. Oh. You do. You do not need a ceramic gauge block set. Yeah, it would be a cool topic. It is one of the classic topics. Mic drop. I couldn't get to the switch fast enough. So it turns out that one of the reasons you use steel gauge blocks is because when you're making a measurement, your part is made out of steel and the coefficient of thermal expansion is the same. As soon as you go to a ceramic gauge block, its coefficient of thermal expansion is different from your parts. Now you need a controlled environment. Think about that. Yeah, so Evil says, of course you need ceramic. How else will guests believe they're not holding on magnetically? That's true. That's absolutely true. Let's see. Does somebody else want to speak? No? Yes? No? Okay. 2 people are typing madly in the Discord server, so we'll see what happens. I think a whole show on gauge blocks would be pretty cool. It's a deep topic and well worth reading about. So Michael Juan says, how much of a concern is gauge block wear? So if you look at your gauge block, Unix, we're going to have some magnetic counseling later. Talk about ceramics. And by the way, Unix, I'm going to tell you this now because you're going to need a little time to recover from it. Yes, there are ceramics which are magnetic. I'm so sorry. How much of a concern is gauge block wear? If you look at your gauge block and it is a mirror finish, maybe it has a couple of minor scratches on it, chances are you have not worn your gauge block to an extent that you need to worry about it. Unix says he just dropped carbide in his coffee. Don't do that. Hey, Joel Ellis here. Joel, welcome. Yeah, you can watch the rest afterwards. Whether or not it's worth it is up to you. So if you send your gauge blocks out for calibration, then you should be more careful than most. If you never send gauge blocks out for calibration, chances are you don't have to worry about it as long as you're not like welding to them. But if you look down at your gauge block and it's dull and scratched up, you may have a problem. Okay. So, look, when you unwrap that gauge block from that greasy paper that has that gouge on it, you will note that the ends of the gauge block are mirror-like, and it's unlikely you're going to wear them and they're still mirror-like. CJ Stevens says, everybody, please make sure you hit that like and subscribe before you go. Thank you very much. I'm not too good at remembering that. And by the way, I know you all already know this, but this is brought to you by PFG Stones, who remind you to get flat and stay flat. Robert Simpson says, all my eBay blocks are, quote, shop grade, close quote. Almost Machining says, a bad gauge block, not on the size, if calibrated, is fine, and the size is traceable. Yeah, so I think I did a video on using PFG stones to clean your gauge blocks. And essentially, it's condition the stone, okay? Use the fine one, the orange one, okay? Condition the stone with the other stone, put it aside, take your gauge block, go whip, 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 and you're done. That's it. And you won't, and if you look at your very nice clean gauge block and gauge blocks, and you say they're perfectly clean, and you go to ring them, and they kind of ring, but they kind of, and then you do what I just told you to do on PFG Stones, and you do it again, you will be a believer. It's like the difference between forgetting the hardener and adding the hardener. Evil says, did we wish people a happy Easter, April 1st, and eclipse viewing? Happy Easter, which is today. Happy April 1st, which is tomorrow. At least that's what they tell us. And happy eclipse viewing on the 8th. I hope you have a place to watch your eclipse. Flatlapper says, happy Easter all, and same back to you and yours. Greenwood says, McMaster 2762 Alpha 58 is a 5/8 11 through hole tap. I probably ordered one of those already. Yes. So that's it. I think we're going to wrap it up. I don't have a cough switch. We're going to wrap it up. If the next PFG goes long, do we get to see the eclipse? It would have to go very long. And almost says run it at about 30 surface feet per minute. I will be lucky if I can get up to 30 surface feet per minute. CJ Stevens says, have a great week. Same to you, Sir Robert Simpson waves, and we wave back. You guys are awesome. I didn't think we'd have this good of a turnout on Easter. Thanks for being here. Enjoy the rest of your day. We will be in the after show roundtable, after party roundtable on the Discord server when we're all done. This will be an audio podcast in about 15 minutes. And I wish you all a magnificent weekend. Don't forget to do your temper, do your cryo, not do your beer. Have an awesome weekend. And remember, get flat and stay flat.